I've seen a lot of videos on YouTube of firemakers using a stick or a rock to grind and ignite mixtures of potassium permanganate and sugar through friction. Most just randomly combine roughly equal amounts of each of the components and grind away to make fire. It looks like it's pretty easy to do and works pretty much every time, but I started wondering if I could improve upon the idea by digging out my old chemistry books and seeing if I could work out the reaction equation. From there, I thought I might be able to determine an optimum mixture to ignite. This video is the result of that quest. Science! Coming up next is a slide that shows the reaction equation for potassium permanganate and sucrose, that is common table sugar. I also list the atomic weights of the various elements involved, and from there I calculate an optimum mixture by weight for sucrose and potassium permanganate. You might want to pause on the next slide for a little while and study it if you'd like. Table sugar, or sucrose, doesn't burn very well by itself. Mostly just kind of melts. But if it's mixed with potassium permanganate and ignited, the mixture burns pretty energetically, as we're going to see in a few minutes. The potassium permanganate acts as an oxidizer and provides oxygen molecules to the sugar as it burns. As shown on the reaction equation slide a few seconds back, I found that the ideal ratio by weight for potassium permanganate and sucrose is about 22 to 3. You're free to pick your favorite unit. I use this little digital scale I bought at Harbor Freight to weigh out 22 grams of potassium permanganate and 3 grams of table sugar, which I then combined in one of these little tins. I also weighed out a approximately 10% rich mixture and another approximately 10% lean mixture. Rich meaning that I had too little potassium permanganate, and lean meaning I had too much. I also created an extremely rich 50-50 mixture for comparison to what other fire makers commonly use. In all the cases, I tried to keep the total weight of the reactants about the same at around 25 grams or so. I'm going to ignite all 4 of these mixtures for you just shortly. Potassium permanganate isn't terribly expensive, but it's not cheap either. I bought 10 1-ounce bottles of the stuff on eBay for about $1.50 per ounce. Potassium permanganate is used in the chemical industry as an oxidizing agent, but it's also used as a medication for dermatitis, for cleaning wounds, and for general disinfection. It's also used for water treatment. By itself, it's safe to handle and use and be around, but since I was going to try to ignite mixtures of potassium permanganate and sugar by friction, I was interested to see if the combined mixtures of ingredients were safe to handle, especially when I treated them roughly. So I did some simple tests. No boom. No boom. Well, I'm glad that part of my little project went well. It appears that if you'd like to mix up some of this stuff and take it with you for lighting fires in the field, it'll be pretty safe to handle and transport, at least if you treat it with reasonable care. All right, let's get on with making some little fires. In this tin, I have a 25-gram mixture, 50-50 mixture of potassium permanganate and table sugar, 12.5 grams of each component. In this tin, I have a 25-gram mixture of potassium permanganate and table sugar. I've got 22 grams of potassium permanganate and 3 grams of sugar. This should be chemically the ideal mixture by weight. In this tin, I have a 23-gram mixture of potassium permanganate and table sugar. 20 grams of potassium permanganate and 3 of table sugar. This should give me an approximately 10% rich mixture. In this tin, I have a 27-gram mixture of potassium permanganate and table sugar. 24 grams of potassium permanganate and 3 of table sugar. This should give me an approximately 10% lean mixture. Well, one thing's for sure. Most people use way too much sugar in their potassium permanganate mixtures. The 50-50 mixture ignited easily and resulted in some big flames, but the near ideal and the ideal mixtures all seem to burn noticeably hotter. Also, after the flames died down on the 50-50 mixture, it left behind a crumbly pile of burnt material that I was easily able to shake off into my backyard fire pit. The ideal and near ideal mixtures, however, left behind what appeared to be blobs of molten lava. And those lava blobs stayed hot for a long time and actually stuck to the scrap piece of 2x4 that I was working with. I had to scrape off those blobs with a stick, and they also caused some really deep charring, as you can see here. It's charred to at least 1/4 of an inch deep, if not deeper. The 50-50 and ideal mixtures both had flames that lasted about 15 to 16 seconds. The slightly rich mixture's flames lasted a bit over 20 seconds, and the slightly lean mixture burned for about 35 seconds. The lean mixture was a little more difficult to ignite than the rest, and the slightly rich mixture seemed to burn the hottest of them all. Overall, I'm pretty confident that the ideal mixture of 22 to 3 is the mark to meet if you're trying to be efficient in the use of your materials. The precise measurements aren't really all that required though. If you want to decide to err slightly on the side of making a slightly rich mixture, that is by adding a little bit extra sugar to the mixture, that's probably okay. Better fire making through chemistry, you gotta love it. Well, science is fun and everything, but at this point in the video you might be asking yourself a couple of questions. One, everything ignited, and seeing that table sugar is essentially free compared to the price of potassium permanganate, won't anything work? Wouldn't anything be sufficient for lighting your campfire? And I'd have to yield the point. Yeah, any mixture will probably do. And the other thing is, if you're going to use friction to ignite a small chemical fire, why not buy yourself a few of these? A box of 250 kitchen matches for $1 or $2 at Walmart. Just saying.